Next up, looking forward to this one, we have Paolo Cremonesi, who's flown over from Milan. Yeah. To come talk to us about LLMs and about the efficacy of them, the accuracy of them. Do you want to have a lucky?
I will.
Yeah, okay. I will. Whatever you like.
Oh, it works. So I have a problem. I'm not able to give a presentation and stay still. So I have to walk up and down. And I hope there is a remote here. Okay, yes. So first of all, I would like to tell you a little bit about myself. I am both the co-founder and CTO of ContentWise, and I'm also a professor of recommender systems at Politecnico di Milano. I've been working and doing research on recommender systems for almost 20 years, mostly applied to the media industry. And what I've done in this long career on recommender systems has been trying to answer to the $1 million question, which is the best recommender system. And how do we try to answer to this question? What we have done, what we are doing is that we benchmark all the best recommender systems that are published or producing by academic institutions, by companies, and we compare them. So it's a huge work. I think over the years we spent more than $1 million of cloud computing to do this benchmarking. And truly speaking, this is really a $1 million question. I don't know if any of you, how many of you do you remember about the Netflix prize in 2010? Okay, there was this competition launched by Netflix about producing what was, according to their idea at that time, the best recommender system for movies, for video. And the prize for the winner was $1 million. And the winner was a team of researchers from Yahoo. And we benchmarked, soon as after the winner was announced, we benchmarked by using industrial criteria, the quality of the recommendations, and we published our results saying that the quality was bad compared to other industrial solutions. So this result attracted a lot of discussions, but after 2 years, Netflix confirmed the claim that that solution was totally useless. So, well, we're still doing this activity. In the past 5 years, we focused our attention mostly on deep learning recommender systems, which are using the same techniques that are used by LLMs. And again, the results of our analysis show that more or less 90% of these recommendation techniques are not good when applied to production systems. But today, I want to focus on LLMs, which is a particular type of technique you can use for doing recommendations, for doing many things, also recommendations. And the results that I'm going to present you today are based on our work, but they've been also supported by a number of other independent studies from academic institutions and private companies such as OpenAI, Amazon, WeChat, and Huawei, and so on. So here you can find a list of these external sources of information. So first of all, if you want to use an LLM for recommendations, how can you use and where can you use the LLMs for recommendations? So this is the overall picture. Now I want to discuss with you where and how we can use LLMs for recommendations. Well, so this is the typical pipeline of a recommender system. So you can use the LLM, for instance, for what we call the feature engineering or metadata pre-processing. So you can use the LLM to improve the quality of metadata, to enrich the metadata catalog, and so on. You can use the LLM to perform what we call the semantic extraction of information from your metadata. You can transform your metadata, and you can extract what they are called the embeddings. There are magic numbers that describe the semantic meaning of your content or the mood of your user. You can use the LLM as a recommender system, as a standalone recommender system. You can ask the LLM to suggest movies or TV series to a specific user. Or you can use finally, you can use the LLM to improve the quality of interaction between the user and the system. For instance, you can you can explain the recommendations. You can implement a speech-to-text system. You can do semantic search and so on. You can use the LLM also in other parts of the pipeline, but we don't care about this today. So today the focus will be mostly on the algorithmic part. So this is for the where. Now we have the question how, okay? And I will use this diagram to describe how we can use an LLM for recommendations. This diagram, in this diagram, each circle represents an experiment. By an experiment using an LLM to do recommendations. The color of the circle and the dimension of the circle are related to the quality and the cost of the recommendation. I will not tell you now how to read colors and dimension of the circles. You have to wait till the end to know, okay? And and as you see, the diagram is divided into four parts, because when you want to use an LLM for recommendations, you have two dimensions of analysis. First of all, you can use the LLM out of the box as it is, so without fine-tuning. So you take the LLM, you take the artificial neurons of this LLM, you don't modify them. Or you can do what is called the fine-tuning of the LLM. You take the LLM, you feed all of your catalog of content, all of the behavioral data of your users into the LLM, you modify the neurons, the weights of the LLM, so that the LLM is going to know much better the behavior of your user base. Of course, this comes at an additional cost. This is one dimension. Another dimension is the possibility to use the LLM alone or to use the LLM in conjunction together with a traditional recommender system. Okay? Well, these are the two dimensions which provide the four combinations. Now, truly speaking, there is another scenario that is you build an LLM for you, a totally new LLM for you from scratch, okay? But I will comment about this fifth scenario at the very end. So let's drill down into these four scenarios. So, and let's analyze these four scenarios in increasing complexity. So this is the simplest approach. You use an LLM out of the box without fine-tuning. Very easy to prototype a recommender system, but you have a number of problems. Low quality of recommendations, because the LLM has a number of, typically the main reason is because the LLM has a number of content bias, cultural bias, popularity biases, okay? And you have also a problem of scalability and cost. Moving on, again, in order of complexity, you can put together an LLM and a traditional recommender system. Typically, you use the LLM to extract you remember the magic semantic numbers, so the embeddings from your catalog, from your content. You feed these embeddings into a traditional recommender system, so you have the benefits of the two worlds. Good quality recommendations, you reduce the cost because you don't need to use the LLM in real time, like in the previous case. You are using it in batch mode. So you solve a number of problems in this way. The other two scenarios require the fine-tuning of your model, either with or without a traditional recommender system. So by fine-tuning the model, the LLM, typically you are able to overcome some of the limitations in terms of quality of a traditional LLM, but again, you have you increase the cost because fine-tuning requires a lot of computational resources. The fifth approach, building an LLM from scratch. Is this feasible? The answer is yes. But in order to build an LLM from scratch, you need to provide to the LLM a huge amount of data, really a huge amount of data. So this makes sense only if you are an hyperscaler. If you are YouTube, it makes sense because YouTube has millions of content, hundreds of millions of users, so it makes sense. But otherwise, it's not. It's not good in terms of quality, in terms of economic sustainability. So now, how do we read this diagram in order to understand if it makes sense? How is the quality of recommendations? Now, I will explain you how to read the colors and the dimension of the circles. So the dimension of the circles is more or less related to the dimension of the LLM. Small circle means a small LLM, so typically a cheaper LLM. A larger circle means a big model, a big LLM with many, many parameters, so a more expensive LLM. And the color is related to the quality. If you have a blue-green color, means that the quality of the recommendations is equivalent to a random recommendation, which is bad, okay? Or at least a popular recommendation. It's like recommending the most popular TV series, okay? Which is totally, it's not useless, but you don't need an LLM to recommend the top popular TV series. If you have a green-yellow color, it means that the quality of the recommendations are more or less equivalent to a simple recommender system, okay? So there is no need to use an LLM. It's just enough to implement a simple recommender system. If you have an orange color, it means that the quality of the recommendations of the LLM are equal or better than the best recommender system available on the market. Okay. Now you can see from the diagram that if you are using an LLM alone, the lower left part of the diagram, the quality of recommendation is totally bad. Okay. And can you guess why? I gave you some hints, but why the quality of recommendation? It's if you experiment with, I don't know, ChatGPT, and you say, okay, dear ChatGPT, I like these and these movies. Can you suggest me something else to watch? And ChatGPT, I'm using ChatGPT as an example, but this works with any other LLM. Okay, you will receive a suggestion which makes sense. Okay, but it's trivial. Okay, it's something that you are able to discover by yourself. You don't need a recommender system to discover this type of content. You see also that if you're using an LLM together with a traditional recommender system, you have a quality which is fantastic. Okay, and for some of the experiments, the dimension of the circle is very small, so you are able also to reduce the cost. Now this is, this diagram is a kind of synthesis of our studies. What companies, what researchers are doing, or what they did in the past. It is curious to know to analyze the evolution of the trends. So at the very beginning of the LLM era, everyone was using LLMs fine-tuned together with traditional recommender systems. Why? Because the first LLMs, the quality, the dimension, the capabilities of the first LLMs were not very good. So the only way to provide recommendations was to fine-tune them and to put them together with a traditional recommender system. Then ChatGPT was released, and there was an hype. So everyone started using LLMs alone. Very easy prototypes, easy to experiment, but as I told you, the quality was not good. And so more recently, let's say the trends are toward using LLMs in combination with traditional recommender systems, so out-of-the-box LLMs in combination with traditional recommender systems, or fine-tuning traditional LLMs. So this is the today trend. If you ask for my opinion, I would stay on the upper left part. Why? Because we have the same quality, but with lower integration effort, lower complexity. You don't do fine-tuning, so lower cost. Okay. I have no idea of the time, so probably I am far ahead of time. So, which is the takeaway from this study? Well, I want to quote, let's say, a sentence from a senior researcher from OpenAI. So they produce LLMs, and on this specific topic, the idea is that LLMs alone are not, let's say, good enough to provide recommendations, good quality recommendations. So the best, you obtain the best of the two worlds if you put them together. So you have a best quality recommendation, reduce the cost, and so on. So thanks for your attention. And this is the same statement, but in my own words. Okay. So depending on the audience, I use one of the two. So thanks again for your attention, and I'm here for questions.
Thank you, Paolo. Can I ask a question? Yes. You mentioned that you can obviously make your own LLM. I mean, you're not really making it from scratch. You're using a framework and putting your content into it. But you don't really have to train it using millions of sources, do you? You would just introduce the metadata for the catalog that you have. So say 4,000 titles, if that's what you've got.
So
or am I misunderstanding?
No, it's a good question. So the question, I'm let's say, reformulating your comment.
Yes.
Does it make sense to, if I want to build an LLM on my own, does it make sense to create a small LLM without billions of parameters by ingesting only my catalog of data and so my information? The answer is yes and no. If you have a very, very small LLM, it doesn't make sense to use an LLM at all. An LLM is one type of AI model. So there are several artificial intelligence architectures or models that you can use, and LLMs fall into the category of deep learning techniques, where the architecture of the model is very complex. By design, you have many parameters.
Yes.
So if you reduce the number of parameters of the model, because we have a small catalog of data to ingest, it doesn't make sense to use a complex model. It's enough, it's even better to use what we call a traditional recommender system. So what are called technically shallow models. Right. Instead of deep learning, deep machine learning, you use shallow learning. Yes. Which is a new way to call the models, the machine learning models that were used, I don't know, 5 years ago, which are still good. Yes. So if a technique is 5 years old, it doesn't mean it's not useful anymore.
So traditional recommendation systems would use content-based filtering?
Traditional, well, the best way to do recommendations is to use both, to use an hybrid approach, which is using collaborative filtering and content-based filtering together. Yes. So you build a machine learning model that put them together.
Is there another way, a sort of Black Mirror, Charlie Brooker style way, which is that the recommender gets to know you rather than the content? And if it knows you, then it knows what to recommend.
A good point. How is it? This is how any recommender system, regardless of being an LLM or a simple model, how is it possible for a recommender system to make recommendations to you, to me? Yes. The recommender system needs to know something about myself. Okay, so the recommender system could know my age, my nationality, my sex. Is this useful to make recommendations to Paolo Cremonesi? The experience is telling us that this type of knowledge is more or less useless.
At that moment.
But the best way to know who I am and my taste is to look at what I've done in the past.
Yes.
And you need to know the historical behavior of Paolo Cremonesi.
Yes.
You need to know information about the content I watched in the past and what other users similar to Paolo Cremonesi have done in the past. Yeah. So if you're able to put the collaborative part, what other users have done in the past, together with the content, you have the best recommended systems, regardless using an LLM or a simpler model.